Hi everyone, this is Mihir Sanishchara and my project is GitHub Data Visualizer. In this presentation, we are going to take a look at the techniques to find trends from GitHub data and some implementations related to it. Main motive of this visualization is to find trends in software industry over the time. There are more than 28 million open source repositories available on GitHub, but there is no good way to find different trends. GitHub shows a trending page, but it just shows 1 month of data in the table. There's no way to answer questions like, does more commit mean more issue? Or which Fortune 500 company is most active in open source community? There are some existing applications like GitHub Visualizer, which shows visualization of commits in the repository by different users or commits by a user in different repositories. It shows different files under the project and commit activity timelines. It also shows who made the most commit over the time. Here are some of the pros and cons of this approach. Basically, you can just focus on single user or repository if you know the name, but you cannot find overall trend from this visualization. Here is another application named Viz. Viz looks more mature than previous application. It shows more visualization and it is written in Tableau. It is available online and offline, allows user to filter specific languages, and it lets user choose X and Y axis as well. Here is one example which shows user with their locations. You can apply filter for specific country and user. There is also an option to filter different languages. Some of the visualization are just the tables where you can apply multiple filter to get the desired result. This is example of box plot for stars of different languages. There is option to change the state from stars to open issues or forks. There are other filters related to languages as well. And all these charts can be shared or downloaded in different format. For this project, I got data from GitHub API version 3, and here's the example format. The screenshot on the left shows the API which just returns the ID and the full name and organization of the repository. Then we get the ID from this and pass it to another API which returns us the metadata of the repository. From there, we can get the size, star count, forks, etc. information for a particular repository. Since GitHub has rate limit API for APIs, I could not build live visualization, so I wrote Python script which would fetch the data and store it to local JSON file. This file is used by the web application to produce the visualization. Some of the relevant visualization techniques are scatterplot, boxplot, bar chart, etc., which I have used for this project. Here is the example of scatterplot matrix. From this visualization, we can find out a relationship between different attributes of repositories. We can even select the data point we are interested in, but there are some limitations. For more than 20 languages, it is difficult to keep track of colors used to identify languages. There is no way to know if project is active or not. As of now, we cannot filter out a single language or view the project name. This is nested tree map example, which shows stars for different languages with the project name. From this visualization, you can quickly find out the most popular language is JavaScript. And we can also see most popular project for each language. For example, JavaScript libraries like React, Vue, Node.js, and then Kubernetes for Go language or Django for Python are very popular. Here is the another example of tree map, with the open issues for different languages, we can see that Python and Go have more issues compared to JavaScript since they have less projects than the JavaScript language. Also, for both languages, we have only few projects which increase the overall count of the issues. There is limitation as well. It is difficult to find projects with smaller number of open issues because they are masked under the larger values. Here's the example of hierarchical bar chart. From this visualization of stars, we can quickly find out the most popular language or project just like a tree map. But unlike tree map, we can also see least popular project or language as well as its name and value. As the number of project and languages grow, there will be a lot of scrolling. To overcome this limitation, we can further introduce more hierarchies, but it will also increase the number of clicks user has to do to visualize the data. Here is the example of radar chart. We can quickly get the idea of size or open issues for different languages, but it doesn't show number of projects. So we don't have any idea of significance of the total. Here is the example of bar chart showing the usage of license. We can see most of the project use MIT license or no license at all. As of now, there is no way to apply filter and find out which projects are under MIT license or any other license. For the fun part, I tried to apply the Benford's law for all the attributes of repository, and we can see it holds true. For the stars in open issue, we can see we got near perfect curve for stars and an acceptable curve for open issues. The other two attributes for fork and size, we got almost perfect curve. This also proves that the data we are using for visualization is not tampered. Some of the insight that we got from this visualization: JavaScript language is the most popular language right now. Projects written in Python and Java have larger size. Projects written in Python, Go, and JavaScript have more number of issues. For JavaScript, number of issues are kind of equally distributed between projects, while Python and Go have unequal distribution of open issues. Most of the authors choose MIT license or don't specify at all. And Benford's law holds true for all the attributes of randomly sampled repositories. For future work, if possible, live API queries to GitHub will be very useful. Find out a way to visualize more than 1 million data points. Based on commit data, find when users are active, different organizations' contributions to open source community. And if we get the 5 years of data, we can show the trend of projects evolving from zero to larger size or getting from active to inactive, and we can even provide plain pause feature for that. These are the references, and thank you for watching.